Let's walk through the related rates quiz review. So number one, a conical tank, vertex down, full of water, is 10 feet across the top and 12 feet deep. If water is flowing out of the tank at a rate of 12 cubic feet per minute, find the rate at which the water level is dropping when the radius of the water level is 4 feet. So here, we're trying to find the rate at which the water level is dropping. Water level is represented by h, or height. So we're looking for the rate, so we're looking for dH over dt. Okay. So here we have our tank, and our dV dt is negative 12 cubic feet per minute, because that's we see water is flowing out of the tank. So we want this 12 to be a negative value, because volume is going to be decreasing over time, and cubic feet per minute also gives you a clue as to that this is dealing with volume, but the rate of change of volume, because we see per minute. Okay. At the moment, that radius is 4 feet, and that is all the information that they give us. Okay. We know we'll be dealing with a volume equation, but we know that we have to get rid of one variable, the r, because we're trying to find dH dt. So we're going to try and rewrite the volume equation in terms of the variable h, because we only have enough information about the height. Okay. Now they do provide us radius, so we do need to do something with that in a minute. But if we want to rewrite the equation in terms of h, we need to find the relationship between radius and height so that we can make that substitution and replace radius in terms of height. So we're going to use similar triangles since we have a cone. So let's split this cone in half, and we're only going to look at the section where this right triangle, similar right triangles are created. So we know the diameter of this tank is 10, so the radius of that tank must be 5. The height of the tank is 12, and the water level at any moment in time will represent r. R will represent the radius of the tank at any moment in time, and h will represent the height of the water level as it's changing. So we can set up similar triangles using radius and height. So we can say small radius is to big radius, so r over 5 is equal to the small height is to the big height, so h over 12. If we do cross product, we get 12r equals 5h. Now let's look here. We want to replace r, so we want to solve for r so that we can get this in terms of height. So if we solve for r, we get r is equal to 5h over 12. So now we can start making our substitutions. Okay, and 5h over 12 will replace r, so r gets replaced with 5h over 12. So we have now, we're working towards volume equation in terms of just one variable, and the variable that we want is h, because we want this to produce the dH dt that we'll be needing to solve for. So we clean this up, and this gives us, clean this up, we get this 25h squared over 144 times pi over 3, and then keep on cleaning this up, and we get 25 pi over 432 h cubed. So we have our volume equation in terms of height. Now we're ready to find the derivative with respect to time. So v becomes dv dt. 25 pi over 432, which is going to be one large coefficient that we keep on the outside. H cubed, we find the derivative, which becomes 3h squared, but we're involving h's derivative, so we have to make sure we attach this dH over dt. Okay. So here is something that we still need to make some adjustments before we plug everything in. let's see what we do have though. We do have dv dt, which is negative 12, so that will just substitute in fine. Here's the problem. We don't have h because they don't give us h. However, they do give us radius. Okay? And let's go back then to see if we can convert radius to be in terms of height using the relationship that we found from our using similar triangles. So since r over 5 is equal to h over 12, we can convert radius to height by simply plugging 4 in for r and solving for h. So 4 over 5 is equal to h over 12. Cross product, 5h equals 48, so h equals 48 over 5. So even though they don't give us height, we can use similar triangles and the radius to convert from radius to height. So now we have height is 48 over 5. We go back to our differential equation, plug 48 over 5 in for h. And now we just have to clean this up. Solve for dh dt. 25 pi, 3, and 48 all goes, 48 squared all goes in the numerator. The denominator is just 432 times 5 squared, which is 25. And then we divide this over to the other side. But first, this actually cleans up a little bit nicely. 25 cancel out. And the numerator and denominator will just reduce to be 16 pi. And then we divide both sides by 16 pi. And we get negative 12 over 16 pi, or negative 3 over 4 pi feet per minute is our dH over dt. Okay, number 2, it's a related problem. It's pretty much the same wording as number 1, but the change now is that it says find the rate of change of the radius of the water level when radius of the water level is 4 feet. So now we're trying to find dr dt. Okay, but everything will remain the same. We're still using the same dimensions. We're still trying to find the rate of change when the radius is at 4 feet. Okay. But now the difference is that we want our volume equation in terms of radius. So that means we want to get rid of the h. Replace the h in terms of radius. So here, if we solve for h, 12r over 5h, which is from the similar triangle that we have from above, 12r equals 5h. Instead of solving for r, we're going to solve for h, so h equals 12r over 5. So now we're going to replace that into the volume equation. And we can clean this up. 12 pi over 15 is coefficient. R cubed is my variable. Which reduces to be 4/5 pi r cubed. So now we can find the derivative. V becomes dv dt. 4/5 pi will stay. R cubed becomes 3r squared, but don't forget we have to attach this dr dt. So let's see what we have. We have dv dt, which is negative 12, same as before. R is 4, so in this case we don't have to make any conversions because we already have the radius. Okay. And now we just have to clean up and solve for dr dt. So this cleans up 4 pi times 3 times 16 over 5. We can multiply by the reciprocal to the other side. So that gives us negative 60 over 4 pi times 48. And then that reduces to be negative 5 over 16 pi. And our dr dt is negative 5 over 16 pi feet per minute. Okay. Or another way that we can solve part B, or number 2, is assuming that we've already found part A, we can find dr dt a lot faster because we already have dh dt. Okay, so let's look at how we can do that. Okay, we already know from part A that dh dt is negative 3 over 4 pi feet per minute. Now, look at this equation that we have from our similar triangles. We already have an equation that relates radius and height. So if we know dh dt, we can use this similar triangle as well to help us find dr dt. And that will make this process a lot easier. Now, we couldn't do this when we were at part A because we didn't have one of these differentials. But here we already have dH dt, so we can find dRt a lot faster. So let's go back and do cross product. We get 12r over 5. So now from here, let's say we want to find the derivative with respect to time. So 12r becomes 12 dr dt. Right, r disappears, but we have to attach dr dt. 5h, the derivative of 5h is just 5, but we're involving h's derivative. We're starting with the variable h, so we have a dH dt. So now we have an equation that's a lot simpler to plug in, because dH dt is simply negative 3 over 4 pi. We can divide the 12 over to the other side, and then we can solve for dr dt, which is 5/12 times negative 3 over 4 pi. And this combines to be negative 15 over 48 pi, which is negative 5 over 16 pi. And then that matches what we did for number 2.